Let's go to experiment number 3. Here comes my incident beam of random oriented silver atoms going into an SGZ device. I again ignore the spin down part of the beam. I take the spin up part of the beam, put it into an SGX device. Let's say there are N0 of those coming in. I ignore the minus X state particles and I take the part that have Sx equals plus h bar over 2. There would be N0 over 2 of those, approximately. And I send them into another SGZ device. What do you think would happen? The answer is you would get a 50-50 split again. Even though all of the atoms that went into the SGX device add plus h bar over 2 for their z component of spin, the measurement of the x component of spin has altered the z component of spin, apparently, because now you get just as many with positive h bar over 2 as negative h bar over 2 coming out of the second SGZ device. So the big story here is that the SGX device changed the state of the particles. Making a measurement of the x component of the spin changed the state, changed the spin of the particles. In other words, after the SGX device, we do not have Sc equals plus h bar over 2 and Sx equals plus h bar over 2. The measurement of the x component of the spin by the SGX device has somehow erased the z component of spin result that we obtained after the SGZ, that we obtained in the SGZ device. Now I'd like to tell you about a so-called modified SG device invented by Feynman. This apparatus has more magnets. Here is an SGZ apparatus just like before, but to make the modified SGZ device, we're going to add further magnets. We're going to add a double length inhomogeneous magnetic field with the opposite direction of magnetic field, and then another single length just like the first one. And we'll send the beam of atoms in like this, and zooming in, exaggerating the effect, the first magnet will tend to split the spin up and spin down particles. The second magnet, first half of the second magnet, will tend to remove the vertical motion because it produces a force in the opposite direction to the first magnet. And then the second half of the second magnet will tend to kick the particles back toward the center, back toward the center line. And the final magnet will again remove the vertical motion and recombine the two beams. So if I was to plot the z component of velocity versus position in this apparatus, if I were to plot the z component of velocity, which is the vertical component of velocity, let's say for the spin-up electrons, the first magnet would tend to produce a positive vertical velocity. The second magnet would take that away and put it back to 0 and then produce a negative z component of velocity. And the third magnet would return the velocity to 0. So the modified SG device splits the beam into two parts and then recombines them. But with the modified SG device, we could in principle block one of those two parts while it's inside the apparatus. So let me make a quick sketch showing what that would look like. Here comes a beam into an SGZ device. I take the SZ equals plus h bar over 2 output and send those guys into a modified SGX device. Let's say there are N0 particles coming in. The modified SGX device would split the beams into two according to the x component of spin. But suppose this lower beam, I just block it. So only the Sx equals plus h bar over 2 part of the beam is allowed to come out over here. There would be N0 over 2 of those. And if I send that into an SGZ device, I would get a 50-50 split on the outputs, because this apparatus is effectively, this setup is just like experiment 3. In experiment 3, I use an ordinary SGX device and ignore the particles with Sx equals minus h bar over 2 and took the ones with Sx equals plus h bar over 2 and sent them in to the second SGZ device.